Alright, just for those. So, just by looking at a compound, how do you know if a compound is an acid? What is special about an acid? Has an H in front, exactly. HCl, HBr, HF. Whatever it is after an H, that is an acid. How do you know if something is a base? OH. Has OH at the end. How do you know if something is a salt? If it doesn't have any of these things, basically. So it's metal and non-metal. That makes it a salt. So NaCl, NaBr, CaF, whatever it is, metal and non-metal. If it doesn't have hydrogen, if it doesn't have OH, it is a salt. So, for example, if I give you HNO3, acid, base, or salt? Acid. So you'd write acid or you write A for acid. What if I give you NaOH? Base. Good question. 6 or 7 questions, but it's 12 points total. So I should probably 12 points, 6 or 7 questions. The questions don't really matter. It's the points that matter. So yeah, it's worth 12 points. So it's it does weigh a little something. So AlCl3.
There's no H in it.
Yeah, so what is it? Salts.
Oh, I forgot about that.
So yeah, if it doesn't have H in it, if it doesn't have OH in it, it is automatically a salt. That's pretty much it with identifying. Nothing more to that. Any questions on this part? Pretty straightforward. So please don't ask me Thursday, how do I know if something is an acid? I can't answer that. Okay? May I move on to the next part? Alright, so this is probably what we're going to spend most of our time in, is the naming. So the nice thing about the naming, yes, it's challenging, but it's only worth 1 point of your entire quiz. So, but it's a good point to have. Okay, so I'm going to start off with just naming bases. So how do you name a base? It's very straightforward. There's no special rules to it, unlike acids. So, start off with bases. So again, bases, they have hydroxide, they have OH, so that's hydroxide. Please don't write HO for hydroxide. That is a common mistake that I see all the time. I almost guarantee you at least one of you will do that. If I see that on Thursday, that means you haven't been paying attention in class. So when you name bases, you just name your metal. And then you name hydroxide. Literally the name hydroxide. So what is the name of CaOH2? Calcium hydroxide. That's it. Nothing more to that. Let me give you the other way around, where you have to write the formula. You just write the name. Oh wait, no, I gave you the same thing. My bad. But yeah, what's the name of LiOH? Lithium hydroxide. There we go. Let me give you another example. Sorry, my brain's not fully working today, so I apologize. Let me give you strontium hydroxide. So you write your symbol, your symbols. What's the symbol for strontium? SR. And hydroxide is what? OH. Good. And then you do charges. Don't forget charges. Whenever you write formulas, always do charges at the very end. So the charge for SR is +2. The charge for hydroxide is always what? 1, -1. So +2 -1, where does that 2 go? The end of OH, and that is it. Easy peasy for bases. Alright, now we're going to get into the acids. Let me know if I'm going too fast, by the way. But I think we're at a good pace. Alright, acids. First, we're going to do name to formula. So when you actually have, like, the word. So the first question you ask yourself is, oh my goodness, I have, like, no room. There we go. The first thing to ask yourself is there hydro in the name or no hydro? Hydro versus no hydro tells you where to go. Okay? So, hydro. Where does that come from? Periodic table or special list? Periodic table. No hydro, special list. So, for example, you have hydroiodic acid. So that's when you look at, okay, hydro, I go directly to the periodic table. What element is iodic? Iodine, so I. So I always put H in front, and that makes it an acid. And then you put I for iodine. What's the very last thing you have to do? Charges. Good. So the charge for hydrogen is always what? 1. What's the charge for iodine? Y'all should have your periodic tables out. -1. +1, -1. Cancel out. So HI. Okay. Alright, so for special list, there's no hydro, so I'm going to give you nitric acid. So since you see this name and be like, okay, there's no hydro, so I have to go to the special list. And again, when you write your formula, always start with an H. And then you look at your list here. So nitric, I have the option of nitrate versus nitrites. So which one is that? Nitrates, because 8 or ick, nitric is 8, because 8 something icky. So NO3. If you put NO2, it would be wrong, so be careful. And then you double check charges. H is +1, nitrate is -1, so it works out for everyone. Everyone's happy. Alright, the other way around, if we have formula to name, this is where it trips most people up, because hydro versus no hydro. It's very tempting to put hydro for every single name. So, your first question to ask yourself, is it periodic table versus special list? If it's the periodic table, you put hydro. If it's special list, no hydro. So a tip that I've done in the past, mainly in high school, when we did naming, right, what I did hydro all the way down, and then I went back and it's like I did hydro, nitric acid, hydro, even if it wasn't supposed to be hydro. And then I went back to those questions, okay, which one is actually from the special list? And then I erased those hydros. So if that helps, you can do that if hydro is really important to write. But again, if you put hydro when it doesn't need to be hydro, then it would be wrong. So careful with that. Alright, so when it comes to the periodic table, the ending is always what? Hydrochloric acid. And then when it's no hydro, there's two possible endings. Ic and us. So how do you know if it ends with ic? 8. Ending with 8. And then us is ending with what? Ites. So 8, something icky. Sprite is delicious. I ate something icky. Sprite is, I'm running out of room, delicious. Alright, let me give you an example. HF. Since that comes from the periodic table, you immediately write hydro. And then what's F? Fluorine, so it turns into what? Fluoric acid. You have to write acid at the end as well. And someone asked me earlier today, like, do I count off for spelling? As long as you don't completely butcher it. If you like miss an O or a U or something, that's fine. As long as you don't put hydrochloric or hydrobromic, like a completely different element for HF, that would obviously be wrong. So if you're close, you'll get the credit. Okay, let's say I give you, oh, I'm giving you a name. Whoopsies. Let me give you something else. HClO2. So what would that be? So again, you're not following these rules here. So do you put hydro or no hydro? No hydro, so go directly to the name of ClO2. Huh? It comes from the special list. Okay, ClO2 is what? Chlorites. So that turns into what? Chloric acid. Okay?
Wait, but it has an H in it. So
Again, it's from the special list, no hydro. Yeah. And the nice thing is, for the quiz, it's only 1 point out of the entire quiz, but you do want as many points as you want, as you need. So, but yeah. May I flip over to the back? Or still need like 30 more seconds?
Are we done with this?
Yeah, we're done with the naming. The last thing I want to cover is conjugate acids and bases. So, alrighty. Let's see. And y'all did pretty well on conjugates, so it shouldn't be too terrible. But it was last week, so maybe some of you forgot. So what does conjugates mean in general? Opposites. So when we have an acid, it produces a conjugate what? Base. Good. And then when we have a base, it produces a conjugate acid. And remember, the left side, these are the reactants, the left side of the reaction, and then these are the products. So another thing you need to know about acids, so what happens to the acids, what happens to the bases. So acids, it all gets to do with the hydrogen. So acids, do they lose or do they gain hydrogen? They lose hydrogen. They lose or they donate hydrogen. Is that cool? Bases, it's opposite of acids, so they gain or they accept hydrogen, because when you look at an acid-base reaction, when the hydrogen gets lost, it doesn't just vanish, doesn't disappear, it goes somewhere else. It goes to the base. So the bases love hydrogen, so they want them. They take it from the acids. So here's what you will be basically given. It's very similar to your practice sheet the other day, like last week. You will be given an equation, and you have to know how to label and which one's conjugate, which one's the acid. So let's say I give you.
Is it H minus for the base?
No, H plus. H plus. Yeah. Let's see. Okay, that's better. Everything is so let's say I give you phosphoric acid, and then I give you NO3. Then I give you HNO3 plus like that. So the first thing you need to do is do a little matchy-matchy, and then you label. So, H3PO4, what does it match with? H2PO4, which automatically makes NO3 match with HNO3. And then you figure out, okay, does it lose, does it gain, what's going on? So H3PO4 to H2PO4, what happens? It loses, so that makes H3PO4 what? Acid. And then the acid makes a conjugate base. Again, always think of it. Please be careful. Don't do acid, conjugate acid. So think of conjugate meaning opposite, and the opposite of acid is base. And from there, it's just process of elimination. If this is acid, NO3 is automatically the base, and it produces conjugate acid. Which makes sense because the base is accepting that hydrogen, so it gained the hydrogen. Is there a question?
But do you have to do choices?
No, it's literally you're given the reaction and then you label. Yeah. So it's kind of like I actually have the worksheet right here.
You have to.
It's kind of like this when you're given like
You
that.
don't have to like find on it.
Yeah. No, none like this. No. Okay, let me give you one more example. You're gonna try it by yourself. Okay. Give you a few seconds to figure that out. It's just labeling.
What if they don't gain?
Big game.
Oh wait no.
Yeah.
Wait, is the minus at the top? It means it.
The minus means it lost the hydrogen.
Okay.
Yeah. Yeah. So H2SO4 goes with H2SO4. Then H2O goes with OH. Again, by the way, I mentioned this before. See how neat this looks? This is what I'm looking for the quiz. Don't scribble. If I can't read it, I can't grade it. Okay, so this is the matchy-matchy that I have here. So from H2O to OH, did it lose or did it gain? It lost. So H2O will be my acid, which automatically makes my HSO4 my base. So since H2O lost, it's the acid, OH became my conjugate. Conjugate base. Careful. So, and then the HSO4 being the base, it produces the conjugate acid. There we go.
And this is just naming, like that's all you do. You just say what you got.
Yeah. You got to do the matching too. It's not just, yeah. Want to do one more? Or you think you're solid? One more. Gotcha. Okay.
So is it possible for you to have the base in front of the acid?
You can. Yeah, that's possible.
So like it could be like HSO4.
Yeah. As long as the acid and base is in the left side of the reaction, it's not on the right side. Yeah. Okay, try that.
Wait, on the first match, is that saying it lost?
Yeah.
And if it loses its base, and if it, no, it did gain its base.
Yes. Yay, nay, hip hooray. All right. So that is half of the review. We will continue this tomorrow with the math stuff, and it should be fairly simple. But yeah, cool.
Wait, I have a,
Yeah.
why on the top one, your base is connected to your conjugate acid? On the bottom.
What do you mean?
I mean on the first graph,
This one?
No, you go up one row. Yeah. Why is the base connected to the conjugate acid on that one?
Did I base conjugate acid? Yeah, because it's the
Opposite.
yeah, it's the opposite. Yeah.